Hi everyone, this is lesson 2.3.3 on applying similarity. So at this point, we've definitely practiced uh, trying to determine if triangles are similar or not, finding missing sides. And so usually once we've learned how to find missing measurements, we try to look at how this might apply in the real world. So this lesson actually has some really good problems on how it applies in the real world. I've only selected one problem for us to kind of go over because I think it's kind of funny. And so this is problem 101 from our books, and it's titled, well, I've titled it, Squawk Like a Chicken. All right, so let me kind of just set up the scenario here. I'll let you, so that's our, in case you're copying that down. All right, so definitely you probably want to set up the problem for this one, draw that out. And so the way this problem goes is, all right, so rumor has it that if you stare into a mirror placed on the ground, if you look down in the mirror and you see someone else's eyes, so if their eyes meet, right, if two people stand staring into a mirror and they both see each other's eyes, that one person will end up squawking like a chicken. All right, so that's kind of the rumor here. And so the question is, how far away do you have to stand from the mirror? And so your victim, assuming, let's say we're on the left side and the victim, if we want to call him the victim, the person that might actually squawk like a chicken, we know for sure they're going to be standing 200 meters. 200 meters away from the mirror. And so the question is, how far do you have to stand from the mirror? All right, do you have to stand 200 as well? Does it have to be 300? And so you might think like, well, it's probably going to be the same, but these people might be different heights. So for example, this person might be close to like 6 feet, and this person's might be close to like 5'1", 5'2". And so because they're different heights, they'd be looking at the mirror at a different angle. So this angle might be different. All right, so what we're going to look at is a couple things. If we're trying to figure out the distance from here, right? So we're going to need to know a height, right? And not the height of the person, but the height of the eyes, right? Because we look at the mirror, we'd be looking at the mirror with our eyes. We don't look at it from the top of our head, all right? So the eyes are looking down, right? The eyes are looking down. So then we need to know what the eye height is. So I've given us some measurements. And so let's say the eye height is about 5 feet 10 inches off the ground. And so just so we have a similar unit and an easier unit, we're told that it's going to be 200 meters. I've given us a unit in centimeters, which is very similar to meters. And I think it's, or I think it should be 200 centimeters on the bottom. So centimeters. All right. I think it's about 200 centimeters. All right, so we have measurements for the person on the left. We have measurements for the person on the right. I intentionally made them a little bit shorter. And so I have the measurements all ready for us. All we need to do is figure out this measurement that I've labeled as X. Now, in case you don't see it, what we do have here is, if you didn't notice, we have a triangle. And assuming this person is standing up straight, it's a right triangle. And then on the other side, we also have another right triangle. So we have two triangles that we could use to help us find the missing side. Right? So in case all the stuff that I have drawn here is confusing, let's look at a simpler version of it. All right. So really what we're looking at is this scenario. All right. So minus the drawings, we're trying to figure out, we're not trying to prove if they're similar or not. We already know, I'm telling you these two triangles are similar. What I am telling you is we need to figure out what this measurement is at the bottom. All right, so then we need to set up a proportion. So when we set up a proportion, what we're going to do is, well, the corresponding sides would be the ones at the bottom. All right, so x and 200. All right, so since I started with x, that's the left side, the 178 from the left side is also going to be on top, and then 152.4 is going to be on the bottom. All right, and so that's kind of how you do it. So in short, here's kind of our situation, real world situation, kind of a funny situation where you think, well, how are we supposed to figure that out? Well, there's actually math you could use to do that, and we've been talking about that math, right? Similar triangles. All right, so that's something you should be able to solve. And so if we cross multiply like we normally do, we've done this in the previous lessons, cross multiply, divide like we normally do, and we get a measurement of 233.596 centimeters. So you should notice this measurement is very similar to kind of how the other person was about to stand. So the other person is standing 200 centimeters away, and the other person is standing a little bit further, which makes sense because they're a little bit taller. All right, so this is not like a million centimeters. It's not ridiculous. So this is a good number, which tells us exactly how far this person should be standing. So this is going to be, what did I say, 233 or something like that? 233. Yeah, so it's about 233 centimeters. So if this person stands that far away, they should be able to see this person's eyes in the mirror, and then they will squawk like a chicken. All right, so that's it for this lesson. That's the only problem I wanted to go over, mainly because there's a very similar problem that usually comes up on a test, and I felt like you needed to see a good example of that. All right, hopefully this was simple and easy to understand.